Brandon Iglesias, he's a... Oh, you scared me. I was like, what? This is someone who's been helping Tab for over like 1-2 years now. He's helping co-organize TabConf. He works at Storj, which is upstairs from here. Give a round of applause for Brandon Iglesias.
Thank you. Okay, so we're not really going to talk about cryptocurrency right now. We're actually going to talk about something completely different. So I kind of want you to like clear your mind. We're going to be talking about decentralized cloud object storage. It's kind of related. Our company actually does have a token, but the token is used to pay for the services that we offer. We're really building just a distributed system. So reset. So who am I? I'm Brandon. I'm the product manager at Storj Labs, which is right upstairs. I help do this kind of stuff. That's my Twitter. I like old motorcycles, like my old motorcycle right there. So what are we talking about today? We're talking about decentralized cloud object storage. What does that mean? Like Amazon S3? Yeah, basically, but it's decentralized. There's a lot of benefits to having a decentralized cloud object storage. And I'm not really going to talk about those things. Some of those things are ideology, like they're like, you know, kind of like stem from like, oh, I want a free currency like Bitcoin. Well, I also don't want to store my data in a centralized server that's hosted by some huge corporation like Amazon. Actually, most of our data is stored in Virginia in Amazon's data center, which is right next to the CIA. Exactly. So if you've ever seen headlines like these, you know, when Amazon goes down, it actually causes huge amounts of trouble. Applications like Slack and Jira, things that a lot of people in the tech industry uses, they go down and there's really nothing you could do about it. I'm going to start with a high-level overview of how the Storj Network actually operates, and then I'm going to dive into a bit more technical details. If you see like an asterisk or an underline, that means I'm going to cover that point a little bit later in the presentation. If you have questions, I want this to be kind of interactive. Just like kind of raise your hand and I'll point at you. And if I'm not going to cover that later, I'll answer your question. So in our network, we actually have 3 actors. We have satellites, uplinks, which are just clients, people who have a bunch of data and they want to store that data in a really secure, reliable, scalable, and cheap way. And then we have storage nodes, which are people like you and I who have computers that are constantly online, and we have big hard drives that we don't actually fill up, like 10 terabyte hard drives. So I want to put my extra hard drives to use, and the way I could do that is I could actually become a part of the Storj Network and get paid for all the data that gets stored on my computer. So what does a satellite do? Satellites are kind of like the puppet masters. They essentially keep track of what storage nodes are holding what pieces on the network. When I say pieces, I'm referring to a file. So we're going to talk about how files are broken down into smaller bits later on. The satellites also repair files on the network. If storage nodes go offline, that means that data is lost, and we have to make sure that we don't actually lose the file. So the satellite is, they keep track of what storage nodes are online and how many are online, and they make sure that the file is still, you could still retrieve your data, essentially. They keep track of how reliable storage nodes are, and they pay storage nodes on the user's behalf. So the way it works is clients end up paying a satellite. The clients upload data to the storage nodes, and then at the end of the month, when the storage nodes come to collect for those services, the satellites actually pay the storage nodes. So what does a storage node do? Their most important job is to store data reliably and be online as much as possible. The most important thing you could do as a storage node operator is make sure that your computer is always online, because there's going to be clients who are requesting the data that they're storing on your computer, and you need to be able to serve that data up. And then what does an uplink do? They store data on the network, like companies. If you have, let's say, Instagram, they have a bunch of data that they have to store, and they want to store that data really cheaply. They could store the data on the Storj Network, and it's great because it's like way better than Amazon S3. So at a high level, what happens when a client tries to upload a file is the client says, hey, satellite, I have this 1 gigabyte file that I want to upload on the network. And the satellite says, okay, I'm going to send you a list of storage nodes to upload that file to. So the satellite responds to the uplink, and the uplink says, okay, I have this list of 50 storage nodes. It encrypts the file, and then it breaks that file up into little pieces, and then it sends each of those little pieces to all of these different storage nodes. And then the uplink will talk back to the satellite and say, hey, I sent all of these pieces to all of these storage nodes. Make sure you keep track of that so that I can retrieve my data in the future. That's at a high level. I'm going to go into way more detail about how files are broken up. Is there any questions so far about how that might work? No? Okay, so what happens when someone wants to download data that they have already been storing on the network? Well, the uplink says, hey, storage node, I uploaded this file a couple months ago, and I need to download it again. Where are these pieces of the file? And the uplink will check its database, and it'll say, well, you're storing the pieces to file A on storage node 1, 2, 3, 4. And it'll tell the uplink what storage nodes are, what storage nodes hold that data, and then the uplink will talk directly to those storage nodes and say, hey, I need my file. Give me all of those different pieces. And then once the uplink has all those different pieces, it constructs the file and it decrypts it. So one of the major aspects of our platform is it's actually client-side encrypted. So the file never leaves the client's computer unless it's encrypted. When I send data up to Amazon S3, it's not encrypted. Amazon can actually look at all of my files whenever they feel like it, unless you encrypt it before you send it to AWS. But most people don't actually do that. So now let's talk about like really technical stuff of how a file is actually broken up. Are there any questions before we go into like the technical stuff? So storage is actually so Michael's asking, what's the real advantage of using storage over like Amazon S3? There's a bunch of advantages. It's not a centralized service, so it's less likely that it's going to be brought down. It's from a hacker's perspective, a lot of people actually attack Amazon and try and get into their services versus storage. You'd have to attack thousands of storage nodes around the world, which is really unlikely. And at that point, you would only be getting little tiny pieces of data that don't actually compile into anything because they've been encrypted and broken up. So even if you were able to decrypt one of those tiny pieces, it would be corrupt data, essentially. It's just a tiny fraction of a file. Aside from that, it's more reliable, and it's just as redundant. We actually have 11 nines of durability on our alpha network. Yeah, 11 nines. Yeah. Yeah. It's like kind of like the gold standard, essentially, and it's cheaper. So, it's about half the price of Amazon. Yeah. So where is storage the most performant? So I will say storage sucks for tiny files. We don't want you to store tiny little files on our network. 4 kilobytes or less is actually really bad because when you store files that are 4 kilobytes or less, we actually don't send them out to the storage nodes because 4 kilobytes is how much metadata we have to store on the satellite to keep track of where all those pieces would be. So instead of breaking up that 4 kilobyte file, what we do is we just store that file directly on the satellite. So at that point, if you have 4 kilobyte or smaller files, you're actually not using decentralized storage. We're just storing your data for you. But it... Okay. Mm-hmm. Yeah. It's actually amazing with streaming videos and movies. So you're downloading data from a whole bunch of people at the same time instead of just a single data source. So we actually don't have to wait. Like if you download a video from Amazon, you're waiting until that entire download is completed. Versus us, if we want to like stream a video and you seek halfway down the video, we don't download the first half of that video. We actually start downloading the video exactly where you want us to play it. So you're downloading less data to your actual machine, which is faster. So we've actually been doing a bunch of speed tests, and internally we have goals in regards to like how fast we are compared to S3, and our last test indicated that we were faster. So I can't tell you how much faster we are, but we're faster, and we're only going to get faster. So. So the satellite has a database that stores something called pointers. The pointers are just metadata about where that specific piece of the file is being stored. So metadata is going to be something like the piece 1 of file A is being stored on node 1. And then the next piece of metadata is piece 2 of file A is being stored on node 2. So it doesn't actually... Go ahead. Okay, so it's secure because it doesn't matter if you know whether or not, like where all the different pieces are. The file is client-side encrypted, so even storage, let's say storage is hosting that specific satellite, even if we download all of those pieces, which we could because we know where they are, it doesn't matter. We couldn't decrypt it because we don't have the decryption keys. So the private key is actually held on the box that encrypts the data, which in this case is the uplink. So if your laptop dies and you don't have your private keys backed up, sorry. I mean, it's like your Bitcoin. You lose your Trezor and you didn't write your private key or your phrase anywhere, your seed, you kind of lost it. So let's take like one more question and then we will keep going into the technical stuff. Yes, absolutely. Oh, so the question is, can you be a storage node? Sorry. So yes, the most important thing about being a storage node is your uptime. If you have like a beefy box that you just always keep on, like becoming a storage node is awesome because you always have uptime. So the satellite, when the uplink asks the satellite for a list of nodes to store a file on, the satellite has this thing called the StatDB on it, and it keeps stats of how storage nodes are. It keeps stats about their uptime, their reliability, how they have passed their audits, if they respond to the uplinks in a timely manner, stuff like that. So essentially, anyone can be a part of the storage network. Well, cryptocurrency mining, it's typically using a GPU or a CPU processing power. We're just storing data on your hard drive. Sure, but probably the majority of your hard drive is still left open, unless you're running like a full node, and then you need like a couple hundred gigabytes. But like typically, you have like a 1 terabyte hard drive, and you could allocate like 500 gigabytes to the storage node network. Yeah, storage.io. You could actually sign up to become a storage node on the Alpha V3 network. So we already have an operational network. It's called V2. There's people storing data. At one point, we had how many petabytes? So we had like 100 petabytes of data on our network, but we decided that we were going to rebuild it because we started hitting scaling issues. So that's what V3 is. It's the third iteration of the Storj Network, and it's going to be like way more scalable, way awesome. Okay, so now I want to talk a little more technical. I'm going to try and keep it. So I've been working for Storj for like 7 or 8 months, and it took me like 5 months to actually learn a lot of this. We're going to learn it in like 10 minutes. It's going to be great. So remember, the uplink asks the satellite, hey, I have a 1 gigabyte file. I want to store the file on the Storj network. Give me a list of nodes, okay? So the satellite responds. It gives the uplink a list of nodes to store that data on. And what actually happens is all of this, what I'm about to explain, happens on the client's computer, okay? So it's just a simple binary that the client would be using to interact with the Storj network. But what happens is we take that file and we break it up into segments. So for the sake of this discussion, let's say that we have a 500 megabyte file and our segments are 100 megabyte sizes. So we're going to break that file up into 5 segments, okay? We take that first segment and we encrypt it. So at that point, we're dealing with encrypted data, okay? And then we take that encrypted data and we break it up into even smaller pieces. These smaller pieces are called stripes. Now, the reason that we're breaking the data down into these tiny pieces, stripes, is earlier someone asked a question about streaming video and performance. We actually don't want to download an entire segment every time someone needs a piece of data. If someone's going to seek a video and only play 2 seconds of it, we only want to download those 2 seconds because that person is actually paying for bandwidth, right? It's not just like they're actually paying to play that video. So we want to be as efficient as possible. So we take that segment, we encrypt it, and we break it up into stripes, okay? So that segment was 100, let's just say 100 megabytes, and then each of these stripes is like 33 megabytes, okay? Now, distributed systems are hard because you could lose data, you can't trust everyone. Like storage nodes can turn off their computers, and then at that point, hey, guess what? You just lost a bunch of the data, right? So you have to build redundancy in the data that you're storing on the network. We used to do this by simply replicating the data 8 times and storing it 8 times over on the network, but that's like really inefficient because like replication is bad, erasure encoding is like way better. So we use this really fancy thing called erasure encoding to build redundancy in our data. Erasure encoding is really awesome algorithm. It's a forward error correcting algorithm, and what it does is it basically oversamples the data that you have. So let's say that we have this piece of data, and we basically just create 1.5 times that piece of data, and then we only need 80% of those pieces that we created to reconstruct all of the data in its entirety. Does that make sense? No? Let me get a marker. 1 second. Yeah, erasure encoding is hard. What? I don't know what hamming is. But, okay, so we have this file, okay? And when you erasure encode it, what you do is you actually just make more of the file. It's weird. You make more of the file. So let's just say that this file is like 100, okay? You actually make like 50% more of the file, okay? And then depending on what your erasure encoding schema is, we use ReedSolomon, if you're wondering. But you actually only need a fraction. So this equals 150. That's how we do math. You actually only need a fraction of this number to recreate the file. So like depending on what your expansion factor is, you may only need 75 of those 150. And then you have the whole file again. So you could lose all of this on the network, but you could still recreate your file. Uh-huh.
So let's say the first file is like 30% of a video clip. So you say 150%. You just take that file, have one copy of it, and then half of a copy of the original copy? Okay.
Oh man, this is hard to explain. So how are you going to?
I'll try to give another example because erasure codes are fun but difficult to conceptually understand. So marker, where's that marker?
Oh, right here.
All right. So the way that I like to explain it is essentially. By the way, I'm Sean. I'm one of the founders at Storj. So work with this guy, awesome guy every day. So the way I like to explain it is you have the Storj Network, right? And let's say you have, and we're just simplifying it as much as possible. There's a bunch of nuances, but you have a file, and you, let's say, for the purposes of this example, you break it into 4 pieces, all right? So you got 1, 2, 3, 4. Now, you could have a case where you have someone who's thrown their laptop out of a window or dropped it in a bathtub and you lose one of those pieces. And that's not good. And so what you can do is you can create a bunch of replicas of this data, like so. And again, you could have another node fail. So ideally, you'd want it to be one of these other nodes, like 1 or 2. But statistically, you could have a chance where the person who's storing that replica of that third piece fails. And that's not good because now you're missing the third piece and you can never reconstruct that data. So what ReedSolomon allows you to do is create essentially these magical, how do I represent magic? A star? I don't know. Yeah, so these extra pieces essentially generated from the data. And what these magical extra pieces generated from the data allow you to do is reconstruct essentially the third piece. And so it gives you a bunch more resiliency in terms of the data, and you have to store much less copies of the data, and there's much less chance of having this weird failure case where you end up losing only 2 pieces, but it happened to be those 2 pieces in that sliver that you needed to reconstruct the data. So it's simply a really interesting mathematical property that allows you to efficiently replicate data, and that's what we use. Yeah, similar to those. Does that make a little bit more sense? So how about you meet me after class and I'll show you the exciting math behind it. It's actually really, really cool, but probably outside of the scope of an overview of Storj.
It uses a polynomial to oversample that data. But so what Sean was saying is actually really important because the pieces, these magical pieces that we create when we erasure encode, each of these stripes are all unique. Okay, so as we have our segment broken down into stripes, each of these stripes gets erasure encoding, which means that we create magical pieces. And then each of those pieces comes down, and then we concatenate each of the erasure encoded. They're called erasure shares. So as a stripe goes through the erasure encoding algorithm, it creates an erasure share, and then those erasure shares get concatenated, and then that concatenation is called a piece, and that's what's stored on the actual storage node. Okay. So one point that I wanted to make is that when you store a file on the Storj Network, you're actually not storing it on like 80 computers because in reality, segments are way smaller than 100 megabytes, and stripes are actually really, really tiny. So you're storing files on, like, a 1 gigabyte file on the Storj network is actually being stored on thousands and thousands of computers. So the chance of all of those computers going down at the same time and us losing enough of these pieces not to be able to reconstruct the file is really unlikely, like extremely unlikely. This is kind of some more stuff on erasure encoding. It's spelled wrong. So what Sean was saying, he used the example for, he has 6 pieces in this example, but we have this number where this is the minimum amount of pieces that we need to reconstruct the file. And then we have this thing called a safety buffer for repair. So once we lose a certain amount of pieces on the Storj network, we're going to start repairing them. And then this is how many pieces we upload initially. And then the 50 we could ignore. That's a nuance. And we could talk about that later if you're interested. It's a long tail problem that comes with distributed computing. So what happens when storage nodes go offline? So as we saw in this example, when storage nodes go offline, if we lose enough storage nodes, if in this example we need at least 20 pieces to reconstruct the file, and we store 40 initially. So if we lose 21 pieces, we won't be able to reconstruct the file. So the satellite is actually responsible for making sure that the storage nodes that are online actually have the data that they say that they do, and they basically keep tabs on all the storage nodes. So we have a few components within the satellite that do this. The auditor keeps track of like if the data that a storage node says that it's holding is actually valid, right? Because a storage node can have a piece of data, but they could go in and corrupt it themselves. So we need a way to figure out like, hey, they have that data. Is that data actually right? If it is, then it's a good storage node. We have the data repair checker, which basically just makes sure that the storage nodes are online and that the storage nodes are responding to uplink requests. And then we have a data repairer, which goes in and repairs pieces of files that are below that minimum threshold that we were just talking about, which is 30. So yeah, that's basically the presentation. This is an open source project. Actually, one of our values at Storj is everything that we do is open source. So if you want to learn more, you could go to our website. You could look at all of the code for the Storj v3 network. You could clone it. You could play around with it. You could actually run your own mini testnet and set up your own satellite and your own storage nodes locally on your computer. It's all documented on our GitHub repo. If you want to engage, we have a Rocket Chat. And then all of this is on our white paper, which we recently released. It's the Storj v3 white paper. If you're going to read it, grab a beer. It's 90 pages, but it's really awesome. We also have an executive summary. If you want to read that, it's only like 3 pages. But a lot of the stuff that I talked about in this quick presentation is detailed out like with concrete implementations of how it's actually operating and why it's going to be scalable. So does anyone have any questions? You want to go first? Yeah.
Good presentation, first of all. I've got 2 questions. Is there a size or a limit on the file sizes that can be uploaded? Mm-hmm. And once you're outside of the client, and say, for example, if I wanted to share the link for one of my files that I've uploaded, if I wanted to send it to someone, will they have to access the software since it has to be decrypted first, or can I just send them the link and then it will, let's stick with the movie example. Okay,
so those are 2 really good questions. Your second question, you won't have to decrypt it. We're building access and file access, bucket access control in the next probably month. We're going to use this thing called macaroons. Macaroons are just a way to give people specific access to specific files without having to do anything about it. So we detail that in our white paper. But yeah, you'll be able to send people a link and they'll be able to stream videos and stuff like that. I could actually pull up a quick demo on my computer if we have like 2.5 more minutes. I pulled the cord so I could connect my computer. What was your first question? Oh, okay, so there's not a limit on the file size. We actually support multi-part uploads. So multi-part uploads are pretty cool. It's something that Amazon came up with. Basically, if you have a 1 terabyte file, it's really unlikely that you're going to send that 1 terabyte file continuously without any hiccups, like no like network latency, nothing like that. So what we actually do is we support any file size, is the short answer, via multi-part upload. So yeah. You want to give?
Great presentation, by the way. I'm so excited for the after school or whatever. After class. So currently, approximately how many nodes are being run as of now? And yeah.
Okay, so our V2 network is still live. I think we have like, I don't know. So at our peak in V2, we had like 100,000 nodes. That's been ramping down because once V3 launches, V2 will be deprecated. Right now, all of the storage nodes for the V3 network are ran by Storj Labs. We're actually in. We just launched our public alpha for developers, and we're going to be launching our public alpha for storage nodes. I don't know if the date is public. Very soon. It's going to be super exciting. I'm really excited about it. We actually have our roadmap and our Jira. Everything that we use is open source. So our roadmap is online. You could go take a look at it. You could look at the specific tickets that we're working on in Jira. You're going to be able to run your own storage node on the V3 network very soon. Okay, Ben.
Hey, thank you for the presentation. 2 quick questions. One, can you give us more details about the payment network? How does that work? How do settlements work? And secondly, are satellite nodes something that anyone can operate, or is that something that Storj will operate?
Yes. Okay, so what happens in our network is the client pays the satellite for how much data and bandwidth it's been using on the network, and then the satellite pays all of the individual storage nodes. The way that the satellite pays the storage nodes is via storage tokens. Well, at least our satellite, which brings me into your second question. We're going to host our own satellite, and we're going to pay the storage nodes that our clients are using in storage token. I assume every other satellite will do the same. But yeah, basically storage nodes get paid for how much data they store and how much bandwidth they use. So the satellite is keeping track of that, and we send out like a lot of payments. We have an ERC20 token, so it's on Ethereum blockchain, and we submit like tens of thousands of payments every month to all of our storage nodes. Right now we're using Web3 something. Talk about that after that.
Last question.
Okay.
You said that you keep track of online time and everything, right?
Yep.
If you're a node and you're running, can you see that information? Like, is there a ranking system or something? Or
On the satellite?
Yeah. So if you said you keep track of that. Well, can the person running the node keep track of that too? Can he see what his uptime is?
In the future, you will be able to, but not in our beta release, which is going to be next year. So right now, the satellite's just keeping track of that. But it's on the storage node to report to the satellite whenever an uplink uses a specific amount of bandwidth. So if you're going to download a file from storage nodes, you're going to ask the satellite where that file is located, and the satellite's going to tell you, but the satellite's also going to send you a blank check. And this is a bandwidth allocation check, and you're the uplink. So you have to send that check to the storage node, or the storage node is going to reject doing business with you, because the storage node won't know whether or not they're going to get paid for sending you that data.
Okay, we are out of time. Can we please give a round of applause for Brandon? Yeah.
Thank you.